right. Someone asked this question. I don't remember whose class it was in, but they wanted to find the derivative of y equal to x squared e to the x minus 2x times e to the x plus 6 e to the x. So we're definitely using the product rule here. And the way we're going to do this, we're just going to say y prime equals. So for x squared e to the x, we're going to have the derivative of x squared, which is 2x, times e to the x, right? We leave the other thing alone, plus the x squared left alone, times the derivative of e to the x, which is e to the x. So that's the derivative of x squared e to the x, minus the derivative of 2x e to the x. Well, again, we're going to think of this part as one part, and this part's another part, just like we did here. The derivative of 2x is 2 times e to the x, plus, and I am using a plus, so I just leave that minus sign out in front, so I'm thinking of this as like all by itself. 2x times the derivative of e to the x, which is e to the x, plus, you could use the product rule here, but you really don't have to, right? The derivative of 6 e to the x is just 6 e to the x. You could also say it's the derivative of 6, which is 0 times e to the x, plus 6 times the derivative of e to the x, which is e to the x. And then I'm imagining this is probably going to simplify somewhat nicely. So let's check it out. We get 2x e to the x plus x squared e to the x minus 2 e to the x minus 2x e to the x, right? That minus sign distributes. And look, those are going to cancel out. Plus 6 e to the x. Simplifying a little bit more, we get x squared e to the x minus 2 e to the x plus 6 e to the x becomes plus 4 e to the x. I would probably leave it like this, but you might want to factor out the e to the x and write it as e to the x times x squared plus 4. And I'll say, one thing I'll say about where we're going with this, I imagine, is eventually we're going to want to anti-differentiate this, and it's going to be kind of complicated. It's going to require something called, oh god, I forgot the word, integration by parts. And so we'll see that the antiderivative of this is equal to this, and it's a somewhat complicated process, not too terrible, but yeah, that's kind of where we're looking towards for this. So there's your antiderivative.